Alright, hello guys, welcome back to the Engineering Principles Advanced course on Learn.io. Today we're going to be talking about torque once again. So you should remember some of the basics about torque from the Engineering Principles basic course. But just to re-jog your memory, Webster Dictionary defines torque as a force that produces or tends to produce rotation or torsion. Basically, instead of moving some object up, down, left, right, a torque rotates an object. But this time we're going to talk about a slightly more complicated formula to solve for torque. So if you remember last time we used the formula tau equals r cross F. Cross basically meaning that the force and the distance had to be perpendicular. Now we're using RF sine theta. Theta being this O-looking thing at the end, which basically stands for the angle at which the force is being applied. So the reason why we no longer need the cross is because sine theta solves for this vertical component of the force. Basically, if you use this equation, you will be able to find what part of the force is perpendicular to the distance. Just to see this in action, let's have a look at a problem down here. So we have our seesaw, our lever, with a force of 2 newtons being applied 4 meters away at an angle of 30 degrees to the horizontal. So we have our equation and we have torque equals RF sine theta. So our R in this case, the distance from the fulcrum, is 4 meters times force. How much force do we have? We have 2 newtons times sine of 30 degrees. Sine 30 degrees, which gives us sine of 30. You don't need to know that off by heart. For the sake of these problems, I recommend using a calculator to figure out sine of 30. However, I do warn if you're using the TI series, you're going to want to go into the settings of the calculator, scroll down to the second row, and switch it from radians to degrees, because if you do these using 30 radians, you'll get a completely different answer. Radians is just another measurement system that we use to measure angles. One that you learned in pre-calculus, but one that we won't concern ourselves with too much right now. So just remember to switch your calculator over to degree mode whenever you're doing problems like this. So we know from pre-calculus we learned the unit circle, and we basically memorize that sine of 30 is equal to 1/2, which is the same as 0.5. So then using that we can simplify down again. 2 newtons times 0.5. That's just times 1 newton, which gives us a torque of 4 times 1 meters times newtons, gives us 4 newton meters. Oh, don't capitalize that, meters. And that's the torque that is ultimately being applied to this lever. So hopefully that helps you understand a little bit more about torque and how to solve torque problems that aren't perpendicular. Thank you very much.